Hello everyone, let's discuss the centripetal force formula. Which is the centripetal force formula? Why is the centripetal force formula like this? It's like this. This is an object with mass m, moving in this direction with a speed of v, if a force is applied to the object, in a direction perpendicular to the velocity. Apply a force. When the force F is equal to mv squared divided by r, the object will move in a circular motion with radius r. This is the radius r. This object, it will move in a circular motion with radius r. Let's analyze this formula. The logic is why it is proportional to it. That's why it is proportional to it, and proportional to its square, and inversely proportional to it. What's the reason for this? Let's imagine, when this object is here, moves in this direction, with a speed of v, its momentum is mv, because its mass is m, so its momentum is mv. When it arrives here, its speed direction has changed, but the magnitude of the velocity is still v. Its momentum is still mv, but its direction has changed. The original momentum was in this direction, but now the momentum in this direction becomes 0, from v to 0. Which means the speed changes from v to 0, and its downward direction changes from 0 to v. The speed increases from 0 to v. This is the force. This force F is perpendicular to the direction of motion of the object. We can decompose it. The force can be decomposed into forces in this direction, and a force in this direction. The force in this direction, it reduces its momentum in this direction. The force in this direction is accelerating. The object generates momentum in this direction. Generate momentum in this direction. That is to say, from here to here, every point can be analyzed like this. Such force analysis. There are two forces. One in this direction. One in this direction. One is the force that stops it from moving, and the other is the force that promotes its movement. This process is like this. In the stage of 1/4 of the circumference, decompose the force. So under the action of this force, under the effect of this horizontal rightward force, during the time it takes to move this quarter circumference, its momentum changed by mv. Under the action of force F, form momentum F. But this F is not this F. This force is this force. Let's assume this is F1. F1 is a variable force. F1 is a component force of force F. This is its momentum, within the range of 1/4 of the running circumference. The change in its momentum, if this counts as F1, then this is F2, component force in the vertically downward direction. So, in fact, the momentum generated by the downward component force is also mv, equal to F2 multiplied by t, and the two times are the same. The magnitude of the force is actually the same, or rather, it is the same in the case of integrating its instantaneous momentum, because their momentum change is the same, and their time is the same. Force F1 and force F2. F1 and F2 are the components of F, but F1 and F2 are changing forces. So this momentum is the average of the impulse integral, right? When the mass is doubled, for example, this object, its mass doubles. If we want to keep other things unchanged, its momentum actually becomes 2 mv. Momentum also doubles, assuming its speed remains unchanged. So the time it takes to run remains unchanged. So the component force F2 will also double. It also becomes twice. The component force F1 will also double. Then in fact, the force F has also doubled. So F is directly proportional to this mass m. Assume its speed is doubled. That is, the speed is doubled, which means its momentum has also doubled. Speed is doubled. Momentum has doubled. Momentum becomes 2mv. But because its speed doubles, it takes to travel this distance, which is 1/4 of the circumference. The time it takes to travel that distance becomes half. Time has decreased, but its momentum has increased by a factor of 2. So, it has to increase the force continuously. To meet this possibility, how much to increase? It can only be increased by 4 times. So, the force needs to increase by 4 times, which is equal to the force F2 being increased by 4 times. F2 needs to be increased by 4 times to meet this demand. Because the time t has decreased, time t becomes half. The force F2 needs to be doubled to meet the requirement of the decrease in time t. But because the momentum has increased, so the time t also needs to be doubled. So the total increase is 4 times. So the square of the speed is proportional to the force. For every doubling of speed, the force will increase by 4 times. The centripetal force has increased by 4 times. This is why it is proportional to its square. Let's look at its relationship with r. Let's look at this r. If the radius is doubled, doubling the radius. If the radius r is doubled, this distance will also be doubled. The result of doubling is that the time it takes to travel doubles. If its speed remains unchanged, the time it takes to travel this distance will also double. Due to the doubling of time, the time is doubled, but its momentum remains unchanged. Momentum does not change. So, the force F needs to decrease. Okay, well, this is the reason why the radius r is inversely proportional to the force F. This is how we use abstract thinking to analyze the principle of centripetal force, and the reason why this formula for centripetal force is like this. What is the reason? It seems that we have basically understood it.